Hey everybody, and welcome to this video on polynomials. So without further ado, let's make it happen. Alright, before we dive right into polynomials, it's going to be important to define exactly what they are. So to do that, we're going to have to start a little simpler. Let's first define a monomial. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. And recall, whole numbers are non-negative integers. So whole numbers are 0, 1, 2, 3, 4, etc., etc. That is, no fractions, no negative numbers as our exponents. So here are some examples of what a monomial is. For example, 5. 5 is a number, so it fits the description. That's a monomial. Or negative x, which we can also think of as negative 1x. That's a number times a variable. That fits the description. That's a monomial. Or h. H is a variable. That fits the description. That's also a monomial. Then you can get a little bit more complicated, like 8m squared. That's the product of a number and a variable raised to an exponent that's a whole number. So that's a monomial as well. We can even get more complicated, like negative 1/2 x squared y to the 5th. This is also a monomial, since it's just the simple product of a number and variables, each of which have whole number exponents. And the long and short of it is, when we have variables, they all represent some number. And so each of these monomials also represents some number. 5 is obviously 5, and negative x, that'll be a number. H, that'll be a number. 8m squared, that'll be some number. And negative 1/2 x squared y to the 5th, that's also going to be some number. So when I think of monomial, I think of one number. All right, now let's define a coefficient. Whenever we have a monomial made up of a number multiplied by a variable or variables, we call that number the coefficient of the monomial. One more definition, the degree of a monomial. The degree of a monomial is the sum of the exponents of the variables. If there's only one variable, and often there's going to be only one variable, it's just the exponent on that variable. So here are some more examples of monomials, and let's use them to find the coefficient and degree of each monomial. All right, let's start with negative 7w to the 4th. We only have one variable, it's raised to the 4th power, so we'd say the degree of this monomial is 4. Since we have negative 7 times w to the 4th power, negative 7 is the number being multiplied by a variable, so negative 7 is our coefficient. In 3/2 d squared k squared, okay, we've got two variables here. They each have an exponent. We just sum up those exponents. 2 plus 2 is 4. So we'd say the degree of this monomial is 4. And the number that's being multiplied by those exponents is 3/2. So the coefficient on this monomial is 3/2. With the monomial x, that's the same as saying 1 times x to the 1st power. Since x is being raised to the 1st power, the degree of this monomial is 1. And since it's a 1 being multiplied by that variable, the coefficient is coincidentally also 1. Remember, if you ever see a variable by itself with no number in front of it, it's implied that there's a coefficient of 1 in front of it. With negative p squared times m, well, we have two variables here. One is being raised to the 2nd power, and one is being raised to the 1st power. M is being raised to the 1st. 2 plus 1 is 3, so we'd say the degree of this monomial is 3. It's a 3rd degree monomial. The coefficient here is negative 1. Remember, whenever we see that floating negative out in front, it's really like there's a negative 1 being multiplied. So the coefficient in this case is negative 1. With negative 8, there is no variable being raised to any power. So we'd actually say that the degree of this monomial is 0. It's just a number, there's no variable at all, and if there's no variable, we say it's a degree 0 monomial. And since there's no variable at all, talking about a coefficient doesn't really make sense because a coefficient means what number is being multiplied by the variable. So the coefficient in this case, we would just say not applicable. There are no coefficients because there are no variables. All right, now that we're feeling good with monomials, it's time to define what a polynomial is. A polynomial is any sum of monomials. That's it. You just sum up a whole bunch of monomials and you've got a polynomial. Remember, each monomial means one number, and a polynomial means many numbers being added together. So here are a few examples of polynomials. All right. Now, let's take a look at our first example. And if we look back at the definition says that a polynomial is a sum of monomials. Well, is this a sum? All I see is subtraction. Well, remember, we can always rewrite subtraction using addition. For example, we can rewrite that polynomial as a sum of monomials, 4x plus negative 5x squared plus negative 8. In our second example, same exact idea. Instead of subtracting 24ab, we can add negative 24ab. And it's the same idea with our last example. And note, we can see from these three examples that even when there are monomials being subtracted from one another, we can very easily rewrite the polynomial with addition. We're probably not going to do this that often, but it's really important to be able to visualize the polynomial using only addition. All right, a few more definitions for us. A term. When we have a polynomial, we call each of the individual monomials being summed a term. For example, in our first polynomial, the terms are 4x, negative 5x squared, and negative 8. In our second example, the terms are 9a squared, negative 24ab, and 16b squared. In our third example, they're 2m to the fourth, negative 3m squared, negative 4m, and 9. One way to think of terms is, a term is just a number, and a polynomial is just a sum of many individual numbers. Just another way to think about it. And note, we're not often going to rewrite these polynomials using addition, so it's really important that when you see a polynomial like this one, you immediately recognize that the terms are negative 5x squared and negative 8. Some people might think it's just regular 5x squared and regular 8. Not the case. Negative 5x squared and negative 8. Now, some polynomials have special names based on the number of terms they have. We've already discussed polynomials with one term. Those are monomials. Polynomials with two terms are called binomials. Polynomials with three terms are called trinomials. And polynomials that have four or more terms being summed up, we just call them all polynomials. All right, now let's define the degree of a polynomial. We've already talked about the degree of a monomial, but the degree of a polynomial is the same as the degree of the term, or monomial, with the highest degree. So let's take a look. In our first example, we've got three terms. We've got a term with degree 1, degree 2, and degree 0. All right, 2 is the highest degree of any individual term, so 2 is the degree of this whole polynomial. For our second example, we have three terms, all of which are degree 2, so the polynomial is a degree 2 polynomial. And in our last example, we've got degree 4, degree 2, degree 1, and degree 0, so we'd say this is a degree 4 polynomial. And again, some polynomials have special names based on the degree of that polynomial. Polynomials of degree 0 are called constant. Polynomials of degree 1 are called linear. Polynomials of degree 2 are called quadratic. Polynomials of degree 3 are called cubic. Of degree 4 are called quartic. Of degree 5 are called quintic. And then after that, you just say 6th degree, 7th degree, and so on. Another definition, the standard form of a polynomial. When a polynomial contains just one variable, for example, all x's or all m's, for example, the standard form of that polynomial is when we order the terms from greatest degree to least degree. So for example, this last polynomial right here is in standard form because it goes from degree 4, degree 2, degree 1, degree 0, and it has all m's. There's no other variables going on. This polynomial up here, it has all x's, but it's not in standard form because it's not going in decreasing degrees. It goes degree 1, degree 2, degree 0. If we wanted to write it in standard form, it would look like negative 5x squared plus 4x minus 8. This would be the standard form of that polynomial. All right, last definition, I swear. The leading coefficient. When a polynomial in one variable is in standard form, we call the coefficient on the very first term, which is the one with the highest degree, we call that coefficient the leading coefficient. So for example, for this polynomial in standard form, the leading coefficient is negative 5. For this polynomial in standard form, the leading coefficient is 2. And for reasons we'll learn later, being able to classify the degree of a polynomial and saying its leading coefficient is going to be really helpful for classifying what type of polynomial you're working with and how it behaves. Now, for the most part, we're going to be dealing with polynomials that have just one variable in them. So let's take a look at a couple examples of such polynomials and practice putting them into standard form, finding the degree of the polynomial, indicating each term, classifying the polynomial with regard to its degree and the number of terms, and finding the leading coefficient. We'll do 2 together, and then I'll have you do 4 on your own. So for instance, 20x minus 4x to the third plus 2 minus x squared. First things first, let's go ahead and put this into standard form right away, starting with the term of the highest degree. So that's negative 4x to the third power. And then we've got a degree 2 term, so minus x squared, then plus 20x, and then plus 2. So now that we've got it in standard form, let's take care of the rest. All right, the degree of the polynomial becomes really easy when it's in standard form. You just look at the first term. The first term has an exponent of 3. That means it's degree 3. And that means the polynomial is degree 3. All right, this polynomial has 4 terms. The first term is negative 4x to the third power. The second term is negative x squared. The third term is 20x. And the last and fourth term is 2. All right, let's classify it. It's a degree 3 polynomial, so we're going to call it a cubic polynomial. And since it's got 4 terms, there's no special name for it other than polynomial. So this is a cubic polynomial. And last but not least, the leading coefficient on this polynomial. Let's look at the first term. That's negative 4x to the third. So negative 4 is the coefficient there. So negative 4 is our leading coefficient. All right, one more. First things first, with negative 6 minus 9a plus 12a squared, let's put it into standard form. The highest degree term is definitely 12a squared, followed by negative 9a, followed by negative 6. So the degree of this polynomial is going to be degree 2, because the leading term is of degree 2, and that's the highest degree term, so degree 2. We've got 3 terms. The terms are 12a squared, negative 9a, and negative 6. All right, let's classify this. It's a degree 2 polynomial, so that means it's quadratic. And since there's 3 terms, we call it a trinomial. So this is a quadratic trinomial. Now, to be honest, it's just really important to know what degree the polynomial is and how many terms there are. Remembering the names quadratic, cubic, quartic, quintic, not so important as being able to communicate, hey, this is a degree 2 polynomial with 3 terms in it. And last but not least, the leading coefficient for this example is 12. All right, so in front of you, you see 4 more examples of polynomials, and please go ahead and put them all into standard form, find the degree, identify the terms, classify them, and identify the leading coefficient. So why don't you pause the video, take care of that, and when you're done, play the video, and we'll see how it went. All right, that's it for this video. I hope you found it helpful, and I hope you enjoyed.